is notes video 7B. 7A was at the beginning of the module, which is normal and typical, and which we would assume. 7B, however, is skipping ahead to the very end of the module. This is because in class, we skipped ahead and we did the second half of the module, and then we're gonna go back and fill in the middle parts. So my later videos will be the middle section. So today we are starting on page 232 and going until the end of the module. Before you watch this video, you should have read in your books about the quantum mechanical model of the atom. The reading begins on page 228, but I have already given notes in class on that. So my notes today are starting on page 232. So again, before you watch this video, please have read in your books from page 228 to the end of the module so that it makes the most sense, because this is kind of tricky, and I hope that I'm explaining it well, but I think it'll make the most sense if you've already read in your book. All right, so we have been talking about atomic structure and trying to visualize and think about what an atom looks like, okay? Atoms are made up of three parts: protons, neutrons, and electrons. The protons and neutrons are always in the same place. They're always in the nucleus of the atom. So when we talk about a quantum mechanical description of an atom, remember the quantum mechanical model is the model of the atom that we understand today. When we talk about a description of an atom, we're really thinking about the electron configuration, because the protons and the neutrons are always in the nucleus, so we don't really need to always describe that. But the electrons, we want to know where the electrons are, because there's a variance there for where the electrons can be. Okay, so let's start by writing that down. Quantum mechanical descriptions of atoms refer to their electron configurations. Quantum mechanical descriptions of atoms refer to their electron configurations. And we talked about electron configurations in class. Actually, no period there yet. My sentence isn't quite over. Quantum mechanical descriptions of atoms refer to their electron configurations, since atoms, protons, and neutrons remain in the nucleus. Remain in the nucleus. That's just not interesting to always say, oh yes, there's protons and neutrons in the nucleus, so we don't even worry about it. We just talk about the electron configuration, meaning where are the electrons. Okay? Now, let's talk about where the electrons would be for a helium-4 atom. Okay, this can also be written like this. Okay, the 4 is the mass number, which is the sum of the atomic number, how many protons, plus how many neutrons. Okay, so in helium-4, we can check the periodic table for the atomic number of helium. The atomic number of helium is 2, which tells us there are 2 protons. Then there must be 2 electrons, because the positive and negative have to neutralize each other in an atom. If there are 2 protons and the mass number is 4, that means there's 2 left over, which are 2 neutrons. Okay? Again, we're not going to worry about talking about the protons and the neutrons. Those are nicely stored away in the nucleus. But these 2 electrons, where would they be? Here's the nucleus. We've talked about energy levels and electron orbitals, okay? The lowest energy level is the first energy level. And electrons are kind of like couch potatoes. They're kind of lazy. So they don't really like to exert themselves. They want to have the lowest energy that they can have. So they stay in the lowest energy level. They stay as close to the nucleus as they can. So the first energy level just has a 1s orbital, which is circular in nature. Now this doesn't mean that the electron moves in a circular pattern. It actually zigs and zags all within this circular kind of round spherical shape, okay? So it's zigging and zagging in there. Actually, there are 2 electrons in there, 1, 2, okay? And they can both fit in the 1s orbital because every orbital can handle or can fit 2 electrons. So they're both gonna be in there, okay? Now let's take a look at let's move up the line to lithium. We'll look at lithium 6. Okay, that's the mass number. The atomic number of lithium is 3, meaning there are 3 protons, 3 electrons, and therefore 3 neutrons, okay? So where are the 3 electrons in a lithium atom? Well, the first 2 are going to be in the lowest energy level orbital, which is 1s. So we have 2 in 1s. The next lowest energy orbital is the 2s orbital, also spherical in nature. So we're going to have in the 1s orbital, we're going to have 2 electrons, because that's as many as it can handle. And then lithium still has 1 more electron, so it's going to go in the next lowest available orbital, which is the 2s orbital. So we've got 2 electrons in 1s, 1 electron in 2s for lithium, okay? Let's take it up a notch and do a bigger atom. Let's try neon. Neon 22. Okay? The atomic number of neon is 10, which tells us we have 10 protons, 10 electrons, and then we must have 12 neutrons, okay? So where are those 10 electrons, okay? This is the order that the orbitals would get filled in. I'm going from the lowest energy orbital to greater energies, okay? Remember, electrons like to stay in their ground state at their lowest energy because they're couch potatoes, because it's easiest, because it wants to be next to the nucleus because of that positive, negative attraction. So the electrons, where are they? Well, first off, there's 2 in the 2s, sorry. There's 2 in the 1s orbital. There would be 2 in the 2s orbital. There would be 6 in the 2p orbital. Because in energy level 2, there are 3 p orbitals. There are always 3 p orbitals, okay? Remember, you can think of one as going kind of up and down, one is going across like this, one is going at another 90-degree angle like this, okay? So in each of those orbitals, this is 1, you can have 2 electrons in there. In this orbital, you can have 2 electrons in there. In this orbital, you can have 2 electrons in there for a total of 6. So the p orbitals on any p orbital, in this case on the second energy level, would be able to fit 6 electrons in. So 6 electrons are going to go. And then we have taken care of 2 plus 2 is 4, plus 6 is 10. We've taken care of all 10 electrons. So that's where the electrons would be in neon. Okay? Now the way that we write this, there's a special way to abbreviate the electron configuration. The electron configuration, we'll write that. Electron configuration abbreviated as, we say 1s, let's start with the lowest energy orbital, 1s, 2, meaning there are 2 electrons in the 1s orbital. Next up is the 2s orbital. 2s, and there are 2 electrons in there, so we put another 2. After 2s comes 2p. 2p, and there are 6 electrons in the 2p orbital, so we put a 6 up there. So the way that we would write the electron configuration for neon 22 is 1s2, 2s2, 2p6. And that is showing a chemist where the electrons are in that atom.